lines, and then the important things to look for is line 2. It's set out, that tells us the output file, and then DOS-G09, so we're going to get a PostScript file, and then we tell it to plot DOS.log, so that's why we have to rename everything DOS.log, because if it's not named that, it's not going to, it doesn't know what file we're trying to go after. So now if we recheck our directory, we should have a DOS_G09 PostScript file. And PostScript file, we don't really know how to open that with a lot of programs, or common programs that we use, so we have to convert it to PDF, which you can just do PS2 PDF write, and then the name of the file. And then after you do that, if you recheck your directory, you'll have a PDF file. You can download that on your local computer, and then you can open it up, and we have a nice little density of space file. So in conclusion, uPlot is free software that we can use to plot data. We can do 2D graphs, 3D graphs. We can write scripts to make it an efficient process to generate our charts, and we can do it quickly in a convenient way.
Okay, let's thank Aaron for the presentation. And any technical, maybe philosophical or scientific questions you wanted to ask him or ask anyone about density of states?
So, first question, can you run this just straight command line without actually entering in like a uPlot script to do it all? Like you can open up a uPlot shell type thing? Like if you just type uPlot, will it open up the program to run this?
Yeah, if you have it on the cluster, it's locally downloaded on there, so you just have to call uPlot, and then it'll run it. But if you wanted to, like if you didn't have it on your local computer, you'd have to download separate first.
Well, I guess, because my second question is, I mean, is there a way that if you run interactively, is there a visual tool that will pop up that you can run off the cluster?
As far as I know, it's just command line driven. There's no graphical interface.
Let me contribute to the discussion. The GNU plot software that Aaron has introduced does have opportunity to do plots. If you look through the script, can you read it?
This one?
Yes. So it does have the set term post, which means the output of this command is established as PostScript file. But you can type set term JPEG or set term X11, which means if you bring everything to the screen. Or if you do not have graphical connection, you can tell set terminal done, which means use approximate representation of text window as a graph. And then with the asterisks and points, it will draw a very ugly picture, but you can see what it is. Okay? So there is a way to generate dumb images. More questions to Aaron. I have one. Can you navigate to the image? And the individual orbitals are represented by peaks with non-zero width. Which physical mechanisms are responsible for this width, or is completely abstract? Is there any mechanism that contributes to width of this individual width?
I believe it's just I convolute it with a Gaussian just to make it look nice, or make it stand out more.
But is there anything behind it? What the width of this Gaussian? How do we select? Do we just blindly repeat what was provided originally, or we can modify and make it wider or thinner? Request help from the audience if someone wants to contribute.
Vibration, rotation, they all
Just
has little contributions.
Thermal motion of complementary technology. More questions to Aaron, please?
What if you want to compare the homo-lumo gap of different species? So, like in the lab we did different alkenes.
Mm-hmm.
what if you want to compare the gap between having 1, 2, 3, 4, 5?
I just kind of overlay them all. Is that what you're saying?
Is there a way to do that?
Not with the script that we use, that we generally use. For this, you'd have to. Well, it kind of depends how you do it. You put all the files that you want in the same directory, and then write a script that calls all of those at the bottom.
But what about the energies? Because they won't line up. Because the script that we have, depending on if you say 1, 2, I think if you do 2 forward or 4, 2, you get, it takes the homo-lumo divide, gets the energy difference, sets it in half, and then that is 0. So like your Fermi energy is 0, and then you can get the difference. Do you know if this script does that as well? So like if you change 1, 2 to 2 different indices, if you could get that?
Off the top of my head, I'm not sure what each column in the file represents.
If you're not sure and you do not want to fight back with demanding definitions, you can probably.
It's possible. There are heroes on the internet who will probably argue on this.
No, it's in the script.
Okay, let's thank Aaron for being brave and sharing our questions through. And we have 2 more presentations in the remaining 15 minutes, which seems reasonable. So the number 9 is by Fest Adrian, who will show most beautiful part of this chapter. He will show how to go to visual representations of molecular orbitals in space. And he will tell his own vision of this problematics. For yours?
All right, so we've been talking about molecular orbitals a whole bunch. Let's look at them. I mean, you get nice pictures in your textbook of atomic orbitals. So what we want to do is we want to visualize molecular orbitals. Again, molecular orbitals are linear combinations of atomic orbitals, but they have to have the same symmetry, which Zach helpfully discussed. And the allowedness, so how much they overlap, determines how much they contribute to each molecular orbital. And very basically, they can either be constructive, where your wave functions add together, or they can be destructive, where your wave functions actually subtract from each other. And you can see here the C alpha and C beta, that's supposed to be C beta. They are your cofactors for how much they contribute to each molecular orbital. So, construction of your molecular orbital files. So we got a check file out when we run the calculations. You need to change that to a fcheck file. So use this command form check. I did O2 because it's a very simple molecule. And I have a check file, and then I tell it the output is a fcheck file. And you get some stuff going on here that tells you, hey, we worked. And then you take that fcheck file and make it a CubeGen file. Now, before you do that, you need to go into your log file, look at where your HOMO is and your LUMO is, or what molecular orbital you want to plot, because in CubeGen, you put the CubeGen, which will generate a cube file. You put that command, then you put O for orbital, because we want molecular orbitals. Then you go MO equals, and in this case I wanted 8 because that was the HOMO for this molecule, the form check file, and then your output. So I called it MO8.cube. But you can, instead of just using an 8, you can use any number that there is an orbital for. You can use HOMO or you can use LUMO, and that will, so then you actually don't even need to know which one it is. You just tell it HOMO and it gives you the HOMO. So just plotting it, we use Gauss view, it's pretty easy to use. You open it up, you open your file with cube extension, and then you go to surfaces and contours in the results. And you get this sweet pop-up box here, and you tell it that you want a new surface, and you can modify your ISO value here to tell it, do we want a higher probability or lower probability? The higher number you put in here, the smaller they get. So if I wanted to, I could plot, you know, very, very small, very, very tight, which is the highest probability area, or you can huge if you want, and fill up your entire screen with green and red bubbles. So modifying for open shell configurations is a little bit different, and it was hinted at earlier, but when we run the Hartree-Fock calculation, you have to tell it what the spin actually is. In this case, I was doing O2. As you know, O2 is ground state triplet because it has 2 unpaired electrons, so I had to put it into the triplet state. And I actually ran DZ on it. Here's the molecular orbital configuration. This is calculated from group theory, so it's mathematically rigorous. And you can see 2 unpaired electrons. Let's see how well they actually, or how well it actually goes in calculations. And so the alpha here is all of the up electrons, and the beta is all of the down spin electrons. And as you can see, my occupied orbitals, there's 2 more in the up, and where we don't have those occupied orbitals for the down spin, which is what we want. But there is a little bit of problem because, as you can see here, these are supposed to be, according to or the previous, they're supposed to be equal to these 2 right here. So HOMO minus 2 should be equal to the HOMO of the downspin, and it's not. So there's a little bit of calculation error in there. Oh, and so when you do the cube gen for these, you need to change, or in front of MOs, you need to tell it you want the alpha or the beta. You have to put a little A or a B. Say, I want alpha or I want beta. Tell it which one you want. And here's the results of that. Here's the alphas, and here's the betas. So this is the highest, and this is the lowest. So I'll get cool pictures.
Okay, let's and presentation is open for discussion. Anything you wanted to specify about?
So you're talking about ISO values, and you're saying that the smaller the ISO value, the higher probability the visual represents the localization, right?
The higher the ISO value, the smaller the spheres, or the tighter it is to the atoms.
Okay. So is there a correlation with like confidence values?
From my understanding, yes. Yeah, from what I read and understood was the higher the value, the higher the probability it's in there. But that's where the electron is at.
Okay, but it's not like there's a direct, like say if it's 0.4, like 0.04, it's a 96%. I mean, there's not no direct. I'm just curious. I don't know.
Probably needs to take orbital square density for analysis of probability. And those are real part of amplitude of probability. Sorry for
That's all right.
train of thoughts. More questions to Seth? I do have one. So, based on your calculations, you show that the ground state of oxygen is triplet.
Yes.
Does it mean that one can pick a drop of liquid oxygen with a magnet or not?
Liquid oxygen should be magnetic, yeah.
So you can, instead of scoop, you can pick liquid oxygen with magnet.
I wouldn't. Liquid oxygen is if theoretically, yeah.
Okay, good. More questions? If not, thanks Tess once again. And in the remaining few minutes, we have the presentation number 10 by Levi Brewster, who will present his understanding of possibility to analyze charge distribution in a molecule based on Gaussian Hartree-Fock calculations from different aspects, from numbers to visual distributions. Floor is yours.
So, first I'm going to talk about Mulliken charge. And how do we get Mulliken charge in our keywords? We actually don't need to specify with Mulliken, they automatically calculate. So if you see, I don't have any pop in here, which pop is for population of orbitals. So when I use the GUI, Gauss view, you can right click and then go down to results, charge distribution. It should say Mulliken. You can choose different things like have a symmetrical range. So for this one, I go from negative 0.7 to positive 0.7. And we can see that the outside is a bit less negative or positive, and the core has more electron density. And you can also look at the dipole. So if you click show dipole, it will show wherever it is pointing. If you want to do it in like an algorithm and you want to automatically pull out, do things to it, you can do grep minus a, number plus 1, Mulliken charges, your file tail number minus plus 2. The reason why you have these numbers is if it's an optimization, it does it twice, so the initial and final. So then for my system, I have 66, so then I do 67 and 68, and then it gives the atoms and then the Mulliken charge. So then you can, if you know which atoms are for your core, you can average that, you can do different things with it, and that can be helpful. So another one which is more precise is natural bond orbital, MBO. And here you have to say pop equals MBO. And you can see the difference between Mulliken and MBO is MBO gets a more accurate number. So these are cadmium and selenium, so they should be 2 plus and 2 minus, but they aren't. The maximum is about -1 and -3/4, and that's due to the basis set not being a full basis set. With the approximations we have, they do not always converge. And these are taking the density of the electron and getting a sphere and integrating in that sphere to figure out the electrons around your ion. And a bond orbital does more where the bond is. Mulliken is just around a sphere. So electron potential, when you do MBOs, you can open them in JMOL, and you can go to surfaces, and there are 2 different ways you can do it. You can visualize it with the bigger one, or bigger values, or smaller ones. So we can see here that these are more red, and it's a bit easier to see than this one because it's pretty much all just blue. So I personally like this one. Total density. So similar to the last presentation, to get the total density of the electrons, we generate a cube, but instead of MOs, we do density, and then there's different keywords you can do, and then when you visualize it, you get an electron cloud around your molecule. Think that.
Okay, let's thank Levi for being a speaker following the schedule. Any questions about charge analysis?
I have a semantic question. So
Yes.
the molecule real
Whatever you prefer.
No. The question was, which specific molecule did you use as an illustration for your presentation?
This is a quantum dot, so it's not molecular.
That wasn't my question, but okay, that works too.
So this is just quantum dot. I had them. I didn't want to recalculate stuff, so I just pulled them open.
More questions? I do have one.
Yes,
So, what is molecular orbital?
it's a linear combination of atomic orbitals.
With some specific expansion
Yes.
coefficients. What is the connection, or is there a connection? What is the connection between expansion coefficients of molecular orbital in basis of atomic orbitals and Mulliken charge analysis on specific atom? What do you see?
I would say that there would be a connection because if you have a high coefficient on a specific atom, then that one electron around it should be attached to that atom, where if you have a very small percentage, then that does not really correlate to around the atom.
So probably you need to take absolute value squared and sum over all occupied,
Yes.
and this will correlate to charge value. Good. Last chance to ask questions to Levi. Pay back for him giving someone hard time. Yes, yes.
What is Millikan?
What is Mulliken? That is a person, I believe. I don't know who Mulliken or what Mulliken is. Is it a person?
So what does the Millikan charge mean? Like,
What do you mean by what does it mean?
Definition.
What is the definition of molecular charge?
the Millikan charge?
It is the electron cloud around the atom, or ion, or nuclei. And if you had a complete basis set, it should converge to the total number attributed to that atom. Does that kind of answer your question?
I honestly don't know the answer, so.
Are you happy with the answer?
So what do you, if you got a plus charge in any atom, like you got a plus, then what does that mean?
I would believe that the nuclear charge is greater than the electron density.
So that number is not electron cloud.
So total charge around that area.
Does anyone want to torture Levi further, or is it sufficient? Okay. If no, let's thank Levi for asking questions and answering questions. So we went through several subjects. I would say very successful. I believe that the presentations by your classmates help you to master your skills in running this software. Because you did hard work in preparing, there is no homework, and you get a substantial amount of points towards your final grade. And from this minute, you are entitled certified experts in running Gaussian software. Well, let me thank all presenters, and the meeting is completed. So let me announce the adjournment.